In the months leading up to D-Day, many prominent German officers, including the famous Erwin Rommel, dismissed the idea of an Allied landing in Europe as absurd. To them, it was a fantasy. Their skepticism wasn't entirely without reason. The Allies faced overwhelming challenges. Even with the full industrial strength of the United States behind them, the task was massive. They would have to assemble an enormous army and a fleet of amphibious vessels on a scale never before attempted. And if they succeeded in landing, they still faced the immense obstacle of the German Atlantic Wall, a heavily fortified defense lined with artillery and guarded by alert, battle-hardened soldiers. Should they manage to establish a foothold in France, they would then need to maintain a steady flow of supplies and fuel across the unpredictable English Channel. The logistics of feeding and fueling such a vast force would be nearly impossible to manage without an extraordinary solution. Despite the odds, the Allies began preparing for this mammoth task. One of their most ambitious efforts was a project known as Operation Pluto. Britain took on the bold challenge of laying massive submarine oil pipelines under the English Channel. This network would become the Allies' vital supply line, pumping millions of gallons of fuel that would power their push to liberate Europe. But secrecy was key. The pipelines had to be installed without the Germans suspecting a thing. When planning Operation Overlord, the code name for the D-Day invasion, the Allies knew their success depended on maintaining a constant fuel supply to their forces in continental Europe. Their army included hundreds of thousands of troops and thousands of fuel-hungry vehicles. A single Sherman tank could use up to 100 gallons of fuel each day. Resistance groups offered help, but their contributions were far from enough to support such a massive military campaign. Early ideas included transporting fuel in jerrycans and using tankers, but these methods were quickly ruled out. Tankers faced high risks from German submarines and air attacks, while ground fuel depots could become easy bombing targets. It became clear they needed a hidden, high-capacity delivery system. Lord Louis Mountbatten, responsible for overseeing the invasion plans, presented a daring idea to Geoffrey Lloyd, the Secretary for Petroleum. Lay oil pipelines across the English Channel. At the time, this seemed almost impossible. Submarine pipelines had only been used for short distances inside ports. Laying one over the long and stormy stretch of the Channel was unthinkable. What's more, the entire line would have to be laid in a single night to avoid enemy detection and tidal disruption. The British War Office estimated that over 60% of the supplies needed by the invasion forces would consist of fuel, oil, and lubricants. While other delivery options were being considered, pipelines appeared the most promising. Meanwhile, the Allies continued producing coastal tankers, manufacturing 20 million jerrycans, and stockpiling vast amounts of packaged fuel in Britain. Still, all of this came with risks. If the Germans managed to stop the tankers, the entire Allied force could be left stranded in Normandy without fuel. The stakes were enormous. Eventually, military leaders decided the pipeline idea wasn't feasible. It was too slow to install, too exposed to detection, and unlikely to meet demand. The idea was abandoned, at least temporarily. Then came a turning point. Clifford Hartley, chief engineer at Anglo-Iranian, visited the Petroleum Warfare Department and overheard a conversation about the problem. Unlike others, Hartley saw the challenge as something that could be solved. Drawing on his experience building pipelines through the harsh terrain of Iran, he proposed a new kind of pipeline, a continuous length resembling an undersea communication cable, but without the core or insulation, and reinforced to withstand pressure. He believed it could be laid by cable-laying ships, with multiple lines installed to increase capacity. This bold proposal revived the pipeline plan under a new name, Operation Pluto, short for Pipeline Under the Ocean. The operation came under the oversight of the Allied Chief of Staff, with leadership from Major General Neville Brown-John and a team of American officers. Captain John Fenwick Hutchings was appointed to manage the mission. The goal was to build flexible pipelines from England to France, delivering fuel straight to the front lines. The plan called for a 130-kilometer line running from the Isle of Wight to Port-en-Bessin in Cherbourg, creating a crucial connection between the Omaha and Gold Beaches. This innovative pipeline system drastically reduced the risk and complexity of traditional supply methods, offering a more reliable and secure source of fuel. Without it, the Allied advance could grind to a halt, leaving troops vulnerable to German counterattacks. Alongside the Red Ball Express, a supply system made up of roads, rail lines, and other pipelines, Operation Pluto became a key part of the Allied logistics network, delivering the massive quantities of fuel needed to drive the liberation of France and the eventual defeat of Nazi Germany. The Allies had learned the hard way about the consequences of being unprepared for amphibious assaults during World War I, when British, New Zealander, and Australian troops failed to advance at Gallipoli and eventually had to retreat. Similar difficulties arose later at Anzio in Italy, where American, British, and Canadian forces faced months of struggle with limited progress and insufficient supplies. Recognizing the importance of petroleum to keep their military machines moving, the Allies invested in a bold project called Operation Pluto, aiming to ensure a steady fuel supply for the liberation of Europe. One of the biggest challenges was building pipelines that could span the English Channel. These pipelines had to be flexible yet strong enough to carry large volumes of fuel. Two types were developed. The HAIS was made from lead and steel wire, while the Hamel was constructed entirely of steel. Former submarine cable factories were repurposed to build the HAIs, with Siemens Brothers manufacturing the lead core cables insulated with paper, armored with steel, and protected with jute and tar. The National Physical Laboratory helped develop a version weighing 55 long tons per nautical mile. However, because lead was scarce, ideas like stripping church roofs were rejected. Instead, the Hamel, which was less flexible but equally large, was developed by engineers from the Iraq Petroleum Company and Burma Oil Company. It was named after its creators, H. A. Hammock and B. J. Ellis. Since Hamel was too rigid for shore landings, its ends were joined with Hayes sections using a special device called the Conan drum. Each Hamel pipe was built from steel sections connected with custom screw joints, and production reached 30 miles per week. This rapid pace was made possible by close cooperation between the Ministry of Fuel and Power, private companies, and academic experts. Work moved swiftly, and testing began on the River Medway in May 1942, followed by further trials on the Firth of Clyde in June. Some HAIS components were even manufactured in the United States to support the project, which was officially included in war planning in June 1942. Testing revealed that pressure inside the pipes had to stay at around 7 bars during construction. Another problem was transportation. British cable ships couldn't handle the massive pipelines, so merchant vessels were converted to carry them. These ships were outfitted with tanks, hauling gear, and guiding equipment provided by Johnson and Phillips. The first large-scale production began on August 14, 1942, using steel from Corby Steelworks. By October, HMS Holdfast was loaded with 30 miles of pipeline. Rehearsals continued through December, with the pipelines surviving rough tests in the Bristol Channel. Encouraging results meant fewer pipelines could be used without reducing the fuel supply. Despite many obstacles, the project achieved success. On June 6, 1944, Operation Overlord began with over 6,000 ships crossing the English Channel. These vessels carried more than 150,000 Allied troops. Naval guns roared across the sea, and over 12,000 aircraft filled the skies. On the ground, tanks such as Sherman's, Churchill's, and Hobart's Funnies began their advance. All of this required vast amounts of fuel, and Operation Pluto was key to meeting that demand. In the days surrounding D-Day, crews worked around the clock to keep supplies flowing. Ships modified for the task laid down the new pipelines, including one converted passenger ship, the London, which carried massive coils of pipe. At one point, a destroyer accidentally hooked a pipeline with its anchor, delaying the process. But on August 14, 1944, the line from the Isle of Wight to Cherbourg was successfully installed, with more lines planned. Several attempts to lay the HAIS and HAMEL pipelines followed, though some failed before becoming operational. Sir Donald Banks, a major figure in the project, explained that while laying cables had been mastered, connecting them at the shore and fixing leaks remained difficult. By September 18th, the final HAIS pipe was ready, and by September 22nd it was operational, though about 3 months late. The Hamel followed and was ready by September 29th. Unfortunately, both pipelines failed on October 3rd due to overestimating how much fuel they could carry. This led to the cancellation of the Cherbourg line. As the war front moved closer to Germany, 17 more pipelines were installed, each linked to hidden pumping stations on the British coast, cleverly disguised as houses and garages to avoid detection. Although Operation Pluto was a marvel of engineering and resourcefulness, its late launch meant it wasn't the primary fuel source during the early stages of the invasion. The Allies had to rely on traditional fuel transport methods like tankers and jerrycans until the Pluto pipelines came fully online. After D-Day, in the wreckage of occupied France, the Pluto system proved its worth. It provided a simpler and more reliable alternative to hauling fuel by truck or ship. Key towns near the Normandy landing beaches, including Port-en-Bessin and Saint-Honorine-de-Perthes, were chosen to host fuel depots for the operation's second phase. On June 9, 1944, work began on the minor system, and after weeks of effort, pipeline fueling became a reality. Between August 12th and 21st, a critical 130-kilometer pipeline was laid from Shanklin in Britain to Courqueville in Normandy. As Allied troops pushed forward, the pipeline extended too, delivering fuel to vital locations like La Haye-du-Puys, Lessay, Saint-Lô, and Vire. Allied forces were able to maintain constant progress as their tanks, armored vehicles, and aircraft were kept operational by a continuously expanding fuel pipeline system. In Normandy, the Allied gasoline service proved vital. Countless vehicles and troops lined up to receive fuel, with filled jerrycans quickly loaded onto trucks and distributed among frontline units, keeping the refueling process alive. The system demonstrated its value through the volume of fuel it transported. By January 1945, an average of 305 tons crossed the English Channel daily. This increased dramatically to 3,048 tons by March and peaked at 4,000 tons in May. From August 1944 to May 1945, approximately 781,000 cubic meters of fuel were sent from Britain to France through underwater pipelines. Despite its innovative design, the Pluto distribution system faced delays that limited its early effectiveness. In December, there was a reassessment of whether to continue with the operation. By then, Allies had access to the port of Antwerp, receiving daily shipments from ocean-going tankers, while smaller coastal vessels supplied Ostend and Rouen. As Allied troops liberated more of Europe, new ports and railways became available, making oil distribution easier and less vulnerable to German interference. As the push toward Berlin advanced, the need for Pluto gradually declined. Eventually, the Dumbo line was connected to a land pipeline system running from Boulogne through Antwerp and Eindhoven to Emmerich. On March 15, 1945, the Dumbo pipeline exceeded its goal of delivering 1 million imperial gallons daily. By April 3rd, deliveries reached 4,500 long tons per day at the Rhine. Pipeline installation continued until May 24th, even as the war's end approached. The system was officially shut down on August 7, 1945, after delivering 180 million imperial gallons of petrol. Operation Pluto was formally closed on August 31st, and the Petroleum Warfare Department ceased operations on March 31st, 1946. Several inventors received tax-free rewards. Hartley got £9,000, Ellis received £5,000, M.K. Purvis, who devised the master plan, received £85, and A.E. Price earned £250 for designing a key anchoring device. Although the effort was massive, the pipeline met only a fraction of the invasion's fuel demands. Between summer and fall 1944, it delivered just 0.16% of the total fuel used. Still, the operation represented extraordinary ingenuity and determination. By the war's end, Pluto pipelines accounted for roughly 8% of fuel supplies sent from the UK to the Allied forces in northwest Europe. During the invasion's initial stages, most oil arrived through the Mulberry ports. Fears of attacks on oil tankers by the German Navy and Air Force, which prompted Pluto's creation, never fully materialized. Nevertheless, the project stood as a symbol of Western engineering strength and the power of unified effort. Operation Pluto reflected the Allies' deep preparation and strategic planning that supported the success of D-Day and beyond. Had the Germans disrupted conventional oil routes, liberation would have slowed, but not stopped, thanks to the secret backup pipeline. By September 1946, dismantling of the pipeline began. The sale of recovered materials brought in more profit than expected, helping cover removal costs. Over time, the operation has been reassessed, with differing views emerging. American naval historian Samuel Eliot Morison highlighted the pipeline's importance in advancing Allied troops deep into Germany. British historian Michael Poston called it strategically important, tactically bold, and industrially challenging. Supporters hail it as a technical marvel that laid groundwork for modern pipeline systems and as a wise backup plan. Winston Churchill called it a wholly British achievement and a proud display of amphibious engineering skill. However, not all opinions were positive. Critics pointed out that Pluto made little difference during critical post-D-Day weeks, when ports were still unavailable. Derek Peyton Smith argued that it failed to contribute when it was most needed. Major General Sir Frederick Morgan also criticized the Bambi section of the pipeline, but acknowledged the value of the Dumbo segment. Traces of Pluto still exist today. Parts of the Bambi line lie at the bottom of the channel, and remnants have been found on the Isle of Wight. Around 10% of the pipelines remain underwater. Operation Pluto represents a bold wartime achievement, merging engineering brilliance with teamwork. It brought together military departments, government offices, and oil companies in a shared mission. The operation's true success lies not in the quantity of fuel it delivered, but in the example it set for innovation and unity. Its legacy is one of strategic thinking, adaptability, and resilience. It was more than just a plan. It was a safeguard prepared for worst-case scenarios. Although it didn't transform fuel logistics as hoped, its technical accomplishments stand out in World War II history. No German device could undermine the level of preparation behind the largest amphibious assault in history. While its direct impact may have been limited, its influence on the war effort and modern logistics was profound. It remains a reminder of the extraordinary measures nations will take when bound by a common purpose.